Hi guys, this is lesson 6.6 and we're going to be graphing and solving systems of linear inequalities. So we spent chapter 5 studying inequalities, so hopefully this lesson will just build on that a little bit. Basically what we do is we take more than one inequality and we put that together on a graph so that we can see an area where our solutions are. So I have graphed a problem here. And you can see that x is greater than or equal to 4 is my pink area, y is less than or equal to x minus 3 is my green area, and then I have kind of lightly blue shaded the place where those two things overlap. So let's do one together. This is on page 374 of your textbook. So I have y is greater than -2, and I have y is less than or equal to x plus 9. So I just need to use the skills that we worked on previously. Let's do that again. There we go. To graph these two equations. So y is greater than -2 is going to be, what's this color? Is going to be here where y is -2, and I'm going to have a boundary line that is horizontal here. There is no or equals to line, so this boundary line is going to be a dotted line. And then I'm going to be shading either above or below that. Since y is greater than -2, then I would be shading up here. All right, then I need to turn my attention to y is less than or equal to x plus 9. So here's where we sort of just pretend that it's y is equal to x plus 9. Plus 9 is my y-intercept, so I'm going to find that. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's right here. And my slope is 1, so I'm going to rise 1 and run 1. And then I'm going to connect my dots here and put a line in. I do have an or equal to bar, so this is going to be a solid line. I can't talk and draw a line at the same time, just like that. All right, so we need to shade either above or below this line. It says y is less than, so I believe I am going to be shading down here. If I were to test the point 0 and 0, that should be a true statement because I think I'm supposed to color that direction. If I plugged those numbers in, 0 is less than or equal to 0 plus 9. Is 0 less than or equal to 9? Yes, it is. That's true. So I'm going to be shading down here. So when we have a system, we want to bring both of these equations together and find the overlap. So I'm going to shade, or look at shading, where these two exactly overlap. So that would be inside of this boundary, down to the dotted line here, and then you can see all of this is where my solutions are going to be. Not down there in the pink where there's only pink, and not over there in the green where there's only green, but definitely in this blue area. And we have one boundary that's dashed and another boundary that's solid. So we will find solutions on the solid boundary, but not on the dashed boundary. All right, let's do another one. Number 3 says y is less than 3x plus 8, and y is greater than or equal to 4x. Okay, we're going to put these on a graph. Y is less than 3x plus 8. Let's grab a color here. Plus 8 is my y-intercept. 1, 2, 3, 4, 5, 6, 7, 8. And my slope is 3. So I'm going to rise 3. 1, 2, 3, and run 1. 1, 2, 3, run 1. I can keep doing this forever. I just want enough that I can aim a line. All right, when I put my line in, it is going to be dashed because there is not an or equal to there. Not sure I'm going to get this very straight. It's pretty bad. This is when it is nice to do your homework in Alex, where you have a little bit better technology for graphing. All right, I need to color to the left or to the right. Since it's less than, I am probably going to be coloring to the right. Let's test 0 and 0 to see if it's true. This would be 0 is less than 3 times 0 plus 8. So 0 is less than 8 is true. So I am coloring. We'll just try to shade that in maybe a little more obviously this time. I am coloring here. All of this is colored over here. So that is just the y is less than 3x plus 8 part of this. And now let's do y is greater than or equal to 4x. So this is one of those direct variations. It's going to cross through the origin. It has no b number there, so it just goes right through 0 and 0. My slope is 4, so I'm going to rise 4. 1, 2, 3, 4, and run 1. 1, 2, 3, 4, run 1. This is interesting because 1, 2, 3, 4, run 1. 1, 2, 3, 4, run 1. Tricky here to get my dots connected. Not perfect. We're going to be coloring greater than 4x. If I were to plug in our 0 and 0, I would get 0 is greater than or equal to 4 times 0. That is true. That doesn't really tell me much. That solution is right on the line. Suppose I did like 1 and 1. 1 is greater than or equal to 4 times 1. 1 is not greater than or equal to 4. So I don't want to color here. I'm going to be coloring to the left of my line. So let's grab some color here. And I would be coloring out here. And all the way up to the line here. We can see where the two areas are going to overlap, and that's going to be where my solutions are, right between these two lines, like this. Okay, we can do one more of those. Find one that's maybe just a little messier. Let's work on number let's work on number 4 because it's not in a nice format. So what do I do if that's the case? So it might be fun to graph one of these in Desmos and look at it. But if it's in standard form like this, sometimes what I want to do is to rearrange it into this form, because that form is so nice for graphing. We wouldn't have to. We could just get some points by plugging in like 0 for x and getting the y-intercept, or plugging in 0 for y and getting the x-intercept. We could do that. Let's go ahead and just rearrange these, and I can show you how to do that. So if I subtract 3x from both sides, then I will have negative y is greater than or equal to negative 3x minus 1. I have this negative 1, which is an issue. So if I thought about dividing both sides by negative 1, I would need to flip my sign. Remember that? And so I would get a positive y is less than or equal to 3x plus 1. So we're actually going to graph this one. And then rearranging the other one, I have 2x plus y is greater than or equal to 5. Just going to subtract 2x from both sides to get y is greater than or equal to negative 2x plus 5. We didn't divide or multiply by a negative, so we have this one. And we can put these guys on a graph. In the first one, plus 1 is my y-intercept. Let's grab a color. It would be right here, and my slope is 3. So I'm going to rise 3, 2, 3, run 1. And I do want a solid line because that or equal to bar is there. I have something that looks like this. And I'm going to shade less than. It's likely that it's going to include this point, so I can test 0 and 0. I will say 0 is less than or equal to 3 times 0 plus 1. So 0 is less than or equal to 1. Yes, that's true. So we'll grab some color here to shade out here. And then we're going to graph the other one. Y is greater than or equal to negative 2x plus 5. 1, 2, 3, 4, 5. There's 5, and my slope is negative 2. So I'm going to go down 2 and over 1. I'm going to have a solid line for this one also because there is an or equal to bar. I think that's going to be a little messed up. Oh dear. Oh dear. Okay. Oh, that's okay for now. So I want to color greater than, which means that if I test my point 0 and 0, it should not work. 0 is greater than or equal to negative 2 times 0 plus 5. 0 is greater than or equal to 5, not true. So I am correct that I need to color away from that point up here. And then what we're looking for is where these two shaded areas overlap. Definitely inside of this boundary, or that boundary is that. And then I didn't shade all the way out here, but that is an included area. And again, in Alex, it makes it really simple. You just tap on the area you want to color in, and it does it. So all of the solutions would be in that zone. These are kind of inequalities create big areas where we have possible solutions. So that's about it for showing you how to graph some of these. You probably just need to practice them. It's very much about just getting our line, just the way we did in the last chapter. So if you have some questions left over from the last chapter, it might be time to ask them. Once we graph in all of the inequalities, then we see where they overlap. You could have 3 or 4 or 5 or even more inequalities in a system like this and still just find the little area where they overlap, and that would be where the solutions were. So this is lesson 6.6. We learned how to solve systems of linear inequalities by graphing them, and yeah, go to Alex and do some practice and ask lots of questions.